Good morning, everybody. Today we are going to go over section 2.4. Okay, and before we do 2.4, we're just going to do a quick warm-up on converting things into slope-intercept form. So slope-intercept form is the one form that we're going to like the most in Algebra 1. And so if we remember, slope-intercept form is y equals mx plus b. Okay, now looking at this, just be sure that we're looking at some key features. Y is all by itself. So if I were to solve and get things into slope-intercept form, I'm technically solving for y. Just like when you guys would solve for x, you were getting x all by itself. Same rules are going to apply. Everything's going to be the exact same. It's just now instead of x, we're solving for y. We're getting y all by itself. All right. Remember that your m always represents your slope, and your b always represents your intercept, your y-intercept on that y-axis, right? So that is the goal. Those are the directions. So we want to convert the following questions into slope-intercept form. So to get started, I have 4x plus y equals 0, all right? I want to get y all by itself, so if I covered up y or I boxed y, I'm going to look around it and say, well, what do I need to get rid of first? And I want to get rid of that 4x. So if I want to move an entire piece of my function, I can only add or I can subtract. And when I look at 4x, I see that it's a positive 4x right now. So in order to move that 4x, I need to subtract it. And whatever I do to one side of my equal sign, I also need to do to the other. And then I can work downwards. My 4x's will cancel, and I'm left with y equals, and 0 minus 4x is just a negative 4x. All right, have a look. Is that in slope-intercept form? Can we identify my slope? Can we identify my intercept? Answer is yes, so let's just do that so we can confirm. My slope here would be a negative 4 because it's paired with my x. It's my m value. And my b does not exist. It's not here on the right-hand side of my mx plus b form. So I know that my b value is going to be 0. Okay. Moving over to the right here, we're going to do the same thing. We're solving for y. We're getting y all by itself. So I find y, and I look around my y, and I want to get rid of this 7x first. So same thing, when I get rid of something, I want to either add or subtract when I'm moving the entire piece. So I'm going to subtract a 7x. All right. Now when I subtract it on the right-hand side of this equal sign, if I go to compare my slope-intercept form, notice that your mx version is first before the constant, all right? So when I go to subtract the 7x, I want to subtract it here in the front, because when I write it, it will now be in slope-intercept form. So if I go and I can continue, I have a 2y that drops down equals negative 7x minus 10. Okay, and then last but not least, again, I'm solving for y, so I'm going to get y all by itself. So if I covered up y here or I boxed y here, I know that I have a 2 right now that's attached. So when it's attached this time, I know that I'm currently multiplying. So in order to get rid of any sort of multiplication, I need to divide. And when you divide, we need to make sure that we're dividing every single thing by 2. Okay, multiplication and division are kind of unique. You have to do it to every single term. So when I do this, I'm going to have y all by itself here. The 2's will cancel each other. I want to leave my slope as a fraction, so don't change it to a decimal. And then negative 10 divided by 2 will give me a negative 5. Okay, remember you're dividing everything by that 2. And we have our final slope-intercept form. All right, let's continue downward here. Question 3, x minus 2y equals -6. Same idea. We first want to subtract an x to both sides, but when I subtract it on the right side here, I want to put it on the left of -6 because they're not like terms. And I have -2y equals -x minus 6. Then I want to get rid of that -2 in front of my y. So it's not saying -2y, it's saying a -2y. You're still multiplying just like we were in question 2. So I still want to divide, but this time I'm going to divide by -2. And I want to divide every single thing by -2. So when I do that, my -2's cancel. And if you look closely on this x, you technically have a 1 with that x. All right, so you have a negative divided by a negative. That's going to give you a positive. And I'm left with a positive 1 over 2x. All right, I understand the x was in the numerator when we divided there, but we can still pair it with 1 over 2 on the side. That's okay. And then last but not least, -6 divided by -2 is a positive 3. Right? Why are we doing all of this? Okay, this is another way that we can write a slope, or we can write a linear function. All right, so we're practicing more on converting linear functions so that I can still identify my slope and I can still identify my intercept so that I can get a point out of it. And then my slope will tell me that I'm going up 1 and to the right 2 with that point. So it's just another way that I can graph. It may not look like a perfect slope-intercept form at the beginning, but we can convert it into such, and then we can make our picture. All right, you will have questions like this on your test, and you will have questions like this on your final, so we want to talk about them. Okay. Question 4, go ahead and give it a try. All right, you will end up with fractions. That is 100% okay. And then go ahead and make your graph as well. All right, so if you need to pause this video, go ahead and pause and attempt this problem. So when we solve for our slope-intercept form, we have a slope of 10 over 3 and a intercept of 0, 5. So I'm going to graph 0, 5 first. And then my slope is going to tell me that I can go up 10 and to the right 3. All right. Well, if I continue to go up 10 and to the right 3 from the point that I just graphed, it's going to be off my picture. But I can go the opposite direction for both. So I can't just go down 10 and still right 3. I want to still go down 10 and to the left 3. If I do that, I will still have a positive slope if I were to draw my guy in and see him walking up the hill. Okay, remember, we can always check that when we are graphing. And he's walking up the hill. So I know that I have a positive slope and my function will look like this. Okay, again, that is just review, so we're talking about it, remembering how to convert things into slope-intercept form. We like slope-intercept form because it tells us our slope and our intercept. Easy peasy. Now we're going to get into section 2.4. All right, And 2.4 is talking about parallel and perpendicular lines. All right. Lines, we're talking about linear functions. Our favorite linear function is slope-intercept form. All right. So go ahead and read through these vocab words for me. All right. In order for you to have any sort of parallel lines, they have to have the same slope. Okay, they can't be parallel unless they have the exact same slope. And then for perpendicular lines, the slopes are going to be opposite reciprocals of each other. All right, we'll talk about what that means here in a second. Okay, reciprocal has come up once already in our notes, but we'll talk about it again. Okay, reciprocal is just the flipped version of a fraction. So for example, if I gave you 1/2 and asked you for the reciprocal of 1/2, all you would do is just flip the fraction and make it 2/1. Okay, but when I talk about an opposite reciprocal, you just have an added step. It's still the flipped version of the fraction, but then we also have to have the opposite sign. All right, so again, if I gave you a fraction like 2/3, the reciprocal, the flipped version, would be 3/2. But since I'm asking this time for the opposite reciprocal, if you started positive, then your opposite would be negative. Okay? So when I ask for perpendicular lines, we're looking for the opposite reciprocal. The sign has to change as well. Okay? So we're going to go through a couple examples here before we get to graphing any of them. So it's saying, will the graphs of the equations be parallel, perpendicular, or neither? So if they're parallel, I'm looking for the same slope. If they are perpendicular, I'm looking for the opposite reciprocal slope. And if they're neither, then they don't have the same slope and they don't have the opposite reciprocal slope. All right, so we're going to go through questions A through D and work them out. So for question A, remember, the only thing we are only focusing on, notice how both parallel and perpendicular have the same reference. We're referencing the slopes. So that's the only thing we want to focus on when we're answering these questions. Okay? So if I look at question A, I'm going to try to identify my slope right away. And when I do that, I look and I say, well, this first function is actually in slope-intercept form. So it should be fairly easy for me to identify the slope. Right now I have m equals 2 on this function. And for the second function, again, I'm going to notice that it's also in slope-intercept form. And so this time my slope is 1/2. All right. Again, we're focusing on the slope, so now I'm going to compare the two. Well, I have a 2 for my first slope and a 1/2 for my second slope. So I know that these are reciprocals of one another, but they are not opposite reciprocals. The sign didn't change. All right. So because of that, I know they're not the same, so they're not parallel, and I know that they aren't the opposite reciprocal, so they're also not going to be perpendicular. So my answer here is going to be neither. Okay, and if I graph these lines, I would confirm that they are neither parallel nor perpendicular. So you can always graph if you need to double check. All right. Going to move down to question B. Same thing. I have the first function, y equals -2/3x minus 1. And the second function, y equals 3/2x plus 3. All right. We're focusing on the slope. So if I want to write slope-intercept form right above it, I most definitely can. If I can write it correctly. Okay, notice how it's in slope-intercept form. All my pieces match very nicely. So I'm going to write down my matching slopes. First one has a slope of negative 2 over 3, and the second one has a slope of positive 3 over 2. So now we'll go in and we'll compare the two. All right, so I first have a negative on the left, and then I ended with a positive on the right, so I know that they are opposites of each other, so that's good. I'll make note of that. And then lastly, I have 2 over 3 that turns into 3 over 2. So I actually flip them as well. So that is what we call a reciprocal. So together, my slopes are opposite reciprocals from one another. Therefore, I know that these two lines are perpendicular to each other. And I have my answer. For question C, we're going to have to do a little bit of work. All right, again, we're shooting for slope-intercept form, so always check, see if it gives us slope-intercept form, because we know that slope is already given to us. So if I wrote slope-intercept form on top, I can compare the two, and I know that my slope is actually given to me nicely on this question. My slope is negative 5. But when I get to C, if I compare the two, I have a y equals mx plus b, but nothing looks even remotely close in the function that I'm given. So this function right here on the second linear equation is not given to me in slope-intercept form. In fact, it's actually given to me a lot like the warm-up questions that we started with. So if I do a quick look and I look up here and just remind myself, how did I solve for y? How did I get it in a slope-intercept form? I can quickly do that on this question here so I can find my slope easily. Right. So to get started, you're getting y all by itself. So I want to get rid of the 25x first. So I'm going to subtract 25x. And I'm going to put it here on the left side of that 1 when I go to subtract it as well. And I have 5y equals negative 25x minus 1. And last but not least, to get rid of that 5 on my y, I want to divide. And when I divide, I have y equals negative 5x minus 1 over 5. I can simplify that fraction, negative 25 over 5. That gives me the negative 5. And now I'm going to compare my slopes. My first slope was negative 5. And when I have it in slope-intercept form on the right here, I know that my other slope is also a negative 5. So when I go to compare the two, I know that I'm talking about the same slopes. Therefore, my answers, or my answer, is telling me that I am working with parallel lines. Okay, go ahead and give question D a try. Again, pause this video if you'd like to try it on your own. You'll notice that it's not given to you in slope-intercept form right away, so we have to find it ourselves. So we're going to do the same thing. Subtract x, subtract x. Divide by 3. So for my first equation, my slope is negative 1 over 3. And then for my second equation, I want to add a 3x to both sides. And I'm left with y equals positive 3x minus 4. So I know that my slope here is positive 3. I look and I compare the two. The first one's negative, the second one is positive. So I know that they are opposites. And then they are also reciprocals. Remember, this is technically 3 over 1. So if I were to flip it, it would turn into 1 over 3, which happens to be the other slope that I have. So I know that they are also reciprocals of each other. Therefore, my two lines are perpendicular. All we are focused on are the slopes of each line. All right, we're going to get into graphing now. Same procedures, but we're going to graph them. All right. So for question 1, it says write the equation of the line that passes through the point. So notice how they gave us a point just now. Hint, hint, wink, wink. All right. And is parallel. Okay, it's underlined and bolded for a reason. It's going to tell us something. It's parallel to the line negative 2/3 x. All right, and then it's asking us to graph the two lines that I know. So if I think about what this question is saying, it's asking me for an equation of a line. I don't know what this line is quite yet, all right, but I know I have to find that equation. And they give me some hints. The first hint is an exact point, okay? Well, if I think of anything that I've gotten out of my forms yet, I know that when I'm given a point, more often than not, I can probably use my point-slope form. So keep that in mind. And then the second piece that they also told me is that they are parallel to one another. So whatever line function I am trying to find, it's going to be parallel to this function as well. All right? And so if I look at that that function that they gave me, I know that parallel lines have to have the same slope. Well, I'll take a look at the function they gave me. Do I have a slope that's given? Yes, I do. So I know that my new equation is going to have the same slope as the equation they just gave me. So now that I know I have to have a slope of negative 2/3, and my new line is going to have the point negative 3, 5, I now have a point, I have a slope, so I can put it in point-slope form. And if you remember, point-slope form looks like this from our notes last class. Okay, so I'm going to plug in what I know. Go back to the point they gave us. I'm going to label them x and y. But more importantly, they gave us 1 point and 1 point only, so I'm going to label it x1, y1. And then I just fill in their respective spots. So x1 has a negative 3, y1 is a 5, and my slope was negative 2/3. So I'm just changing out my y1, my m, and my x1. Everything else is going to drop down, including the minus signs that I had before in my function. All right, and I want to include those minus signs because we will see what happens. Now we have, if I simplify, y minus 5 equals negative 2/3. And on the inside here, a negative and a negative is going to turn into a positive. And I have y minus 5 equals negative 2/3, parentheses x plus 3. All right, so I have my new function. This, my friends, is my new function that they were asking me for. But then they asked me to also graph. So make sure we're following the directions, okay? More importantly, it asked me to graph both lines. So I want to prove that they are indeed parallel to one another. That's why graphs are helpful. When in doubt, graph it out. That's my phrase, okay? So I'm going to graph this first function here. Y equals negative 2/3 x. It's in slope-intercept form. We've already identified that my slope is negative 2/3. And my b here is going to be 0, which tells me that I have a coordinate at 0, 0. Put the point there. My graph, or my slope, is going to tell me to go down 2. and to the right 3. Down 2, right 3. Down 2, right 3. Or I can go up 2, left 3 if I want to continue the correct pattern. Connect the dots, and I have my first line. Okay, if you want to graph these lines prior to doing any work, you totally can do that too. All right. For the second one, okay, think about what was told to us. I can do it one of two ways. I can distribute this fraction and then add that 5 over and get it in slope-intercept form. And if I do that, I have negative 2/3 x. That gives me negative 2, so it would be plus 3. So we've talked about converting point slope into slope-intercept form. So if I did that, I would have y equals negative 2/3 x plus 3. I can graph my slope with my intercept at 3. Or think about what they told us. They told us a point. Can I use that point and graph it on my line as well, or graph it on my picture? Yes, I can. I know that that point exists on the line that I'm given. And then I can use the same slope, which told me to go down 2, right 3, down 2, right 3, down 2, right 3. Or if you wanted to use this function, you would say that your b is at 3, so you could put a point at 0, 3. Take a look at one of my coordinates. I actually happen to have a point already at 0 at 3. So I know that I am okay and I am good to go. So if we compare these two lines to each other, are they ever going to cross? Okay, if they're parallel lines, they are never going to touch one another. So they are going to be quite okay. And I know that my answer is correct. Okay, question 2 is very, very similar. Go ahead and give this one a try. All right, they're looking for a function that passes through the point 0, 3. And again, it's going to be parallel. So think about what parallel means. And at the end, we will graph the lines. So if you would rather graph this line first before you get started so you don't forget about doing it later, you most certainly can. So right now, my slope is 5 over 4, and my b is negative 1. I can put a point at 0, negative 1, and my slope is going to tell me to go up 5 and to the right 4. Up 5 to the right 4. All right, if I want another point, I can also go down 5 and to the left 4. All right, so I haven't fully solved question 2. All I've done is just made my graph. Now I can go and look and see if I can figure out what this line is that they're talking about and wanting me to graph. All right, so again, I'm given a point, and I know that it has to be parallel. So if I compare the slopes to this given function that I have, I know that, again, they have to be the same. So now I know what my slope has to be, and I'm given another point, so I can put it in point slope form. So the only things I'm going to change out is my x1, my y1, and then my m for slope. So y1 will get switched with a 3. Slope will get switched with 5 over 4. And my x1 will change out with a 0. Everything else drops down, including the minus signs in the formula. And I have my point slope form. All right, I can distribute and solve if I want my slope intercept form. And if I do that, this whole thing will convert to y equals 5 over 4x plus 3. Or I can use the point that they gave me. Either way, it's still going to give me the coordinate 0, 3. Tells me to go up 5, right 4. That's going to be off of my picture. So I'm going to go down 5, left 4. And connect my dots. All right. And just as a check again, we can go in and we can say, well, they have to be parallel. Take a look at my picture. Visual representations are very helpful. Are they parallel to one another? Are they never going to cross? Do they represent the same slopes? And your answer to all those should be yes. And for the last two questions, this time instead of parallel, we're going to talk about perpendicular. But the same procedure is going to happen, all right? The only thing is that when I have perpendicular lines, I need to remember that the slopes are opposite reciprocals of each other. This time they're not the same, they have to be opposite reciprocals, okay? So I like to graph the lines first, so I'm going to graph the line that they gave me first. So I know that my slope is 2, if I want to make a fraction, 2 over 1. And my b is negative 3. Plot that point. My slope is telling me I need to go up 2 and to the right 1. Up to right 1. Continue the pattern so we can get all of our points on our picture so that we can connect the dots and make an even straighter line. Okay, my line's not the greatest, but that's okay. So now I have this line, and I know that the line that they're asking me for, the second line, has to be perpendicular to the one I just graphed. All right, so they gave me a point. I'm just going to write that point here because it looks kind of stuck in all those words, so I'm just going to write it off to the side so I don't forget. And then my slope for perpendicular has to be the opposite reciprocal. So if I know one slope, which I happen to already know, I know that one line has a slope of 2 over 1, so my new slope for my perpendicular line has to be the opposite. So if it started positive, my new slope has to be negative now. And then the reciprocal is the flipped fraction. So instead of 2 over 1, I want it to have 1 over 2. So my new slope has to be negative 1 over 2. I'm given a point, so I know that this is x1, y1. I can plug it into my point slope form. Again, it's looking for the function. So even if you can graph it, great, but we also need the function. So make sure that you're writing the equation as well. My y1 is going to get replaced with 5. My m gets replaced with negative 1 over 2. And my x1 gets replaced with 4. Everything else will drop down, including the minus signs. Don't forget the minus signs. All right. And then I can graph what I know, or I can also distribute, and that gives me negative 1 over 2 plus 2. Don't lose with fractions. All right. And then add 5 to both sides. And my real slope-intercept function, oh, I forgot my x, should be negative 1 over 2x plus 7. So if I go and I graph 0, 7 is not on my picture, but I also happen to know a point that should be on my picture. So I can graph 4, 5. I know that's on my picture. That's quite okay. So 4, 5 is actually right here. It's touching that other line. That is fine. But my new slope of -1/2 is telling me I need to go down 1 and to the right 2. So that's going to be the difference between one line to the other. They're going to have opposite reciprocal slopes. So when I graph them, my second line, my new line, will look like this. And take a look. If they are perpendicular, they should be crossing over one another at a 90-degree angle. And that is the case. So I am good to continue on to the next question. Okay. Remember, you want your function too. So if you want to put your function in slope-intercept or point-slope form, I will accept that. Or if you convert it into slope-intercept form, I will also accept that. But I need to have both. If the directions are asking for both, please make sure you are writing both. And the last question, go ahead and give it a try. Pause this video, see how you can compare to what I have shown up above, and get some practice. All right, it's asking for perpendicular again. So I know that I'm working with the opposite reciprocal slope. All right, but before I get started, let's go ahead and graph this function here. So my slope right now is a -3. Let's make it a fraction. And my b is 1. Make the coordinate. And then my slope is telling me I need to go down 3 and to the right 1. Down 3, right 1. Down 3, right 1. Make my line. This is just the line that they gave me. I still have to graph my new line and figure out what that function is. So if I know that I have to have a opposite reciprocal slope of the one I'm already given, the opposite of -3/1 is going to be a positive. So I'm working with a positive slope, and then when I flip it as the reciprocal, I should end with a positive 1/3. I'm given the coordinate -3/2. So I label them x1, y1. Put it into point slope form because I was given a point and slope. Change out my y1 with a 2, my slope with a 1/3, and my x1 with a -3. Bring down everything else, including that minus sign. I see I have a double minus. So I have an x plus 3 in those parentheses. All right. I can graph the point that they gave me, -3, 2. And my new slope is telling me that I need to go up 1 and to the right 3. Up 1, right 3. Up 1, right 3. Put a point there. I can put another point here and connect the dots. Okay, so for this one, they don't share a point, which is quite okay, but they do still cross one another. And so we are okay. If you are someone who likes to write it in slope-intercept form, if I convert this function into slope-intercept form, I'm left with y equals 1/3 x plus 3 again. Okay, so either way, I need to see the function. Doesn't matter if you put it in point-slope form or if you change it into slope-intercept form. I need to see one or the other, as well as the graph. So that is all for today. As far as your homework goes, you will have a worksheet that pairs along with this, the 2.4 worksheet. And then when we come back from fall break, you have your test. So you will also be assigned your study guide for that test. All right, so you'll have 2 assignments opening today, and be on the lookout for those. You have all of fall break to work on it. I will be available via email if you need me for anything, so please ask your questions. I know